Let's go ahead and look at how we can go about solving exponential equations, and we're going to solve them using logarithms. So I have a few exponential equations that we'll be able to solve listed here, and I'd like to explain how to solve them by using some examples. Now, before I show you these examples and what to do in them, I'd like to say when this is going to work. When does this method work? So this method will work when you can do one of two things. You can express your problem as a number to a power involving x. So power involving x equals another number. Or if you can express your problem as a number to some power involving x equals some other number to some other power with x. So if you can do one of these two things, then this method will work. Of course, I haven't told you the method yet, but we'll start talking about that now. So let's start with a. 2e to the 3x minus 17 equals 0. I believe that's what a was. Now this is not written as a number to a power involving x equals another number, but we can write it in such a way. We can do that by adding 17 to both sides. We would obtain 2e to the 3x equals 17 over 2, and then I think I got a little bit ahead of myself. We would get equal to 17. Then we can divide by 2. And finally, we get e to the 3x is 17 over 2. And this form here is the same form as 1. It is a number to a power involving x equals a number. We have a number e to a power involving x, 3x, equals another number. Once you get it in this form, then you can take logarithms of both sides. And you'll see exactly why this is useful. If I take ln of e to the 3x, and I take the logarithm of the right-hand side equals ln of 17 over 2, then you can use properties of logarithms to make this 3x drop down, and you get 3x times the ln of e equals ln of 17 over 2. Now ln of e is 1, but I'm just going to leave it as ln of e for just a moment. And I want to make the observation, the key observation that is, of what just happened. We've taken our equation, which had an x in the exponent, and now it just has x multiplying numbers. That is, our equation is now x times 3 ln e equals ln of 17 over 2. And ln of e is a number. What's important here is we have x times a number equals some other number. And we already know how to solve equations like that. So for example, if you have x times 7 equals 5, then we know that x is 5/7. X times a number equals another number is very easy to solve. We just divide by whatever the x is multiplying. So we'll go ahead and divide by what the x is multiplying here. And we would get that x is equal to ln of 17 over 2 divided by 3 ln e. And I think I'll just go ahead now and cross this out because ln of e is 1. So this is ln of 17 over 2 divided by 3. So let's pause for a moment, make maybe one or two observations, and then outline what the solution method is here. So the first observation is, notice that I did not put this ln of 17 over 2 into a calculator. When you are solving these types of problems, unless you have something like ln of e being 1, we typically don't write decimal approximations for the logarithms that come up. So that is, I will not type this into a calculator and get a decimal. I will just leave it as whatever it is. In this case, ln of 17 over 2. However, you should be expected, or you should expect to be able to simplify logarithms that can be simplified. So for example, this ln of e is 1. That's a simplification that you should make. Another observation that I'd like to make is, depending on the logarithms that are used in a problem, your answer may look different than someone else's answer, but still be equal. Let me show you what I mean by this. Let's say, for example, we got to this step, so let's go ahead and rewrite it. E to the 3x equals 17 over 2. In my solution, I put ln. I took the natural logarithm of both sides. But you can also obtain a solution by taking the common logarithm, or any logarithm that you'd like, actually. So let's see what happens if we would take log base 10. So if you take log base 10 of both sides, then this 3x still drops down due to properties of logarithms. So 3x log e equals log of 17 over 2. And now I divide both sides by 3 log e. And what I obtain is that x is equal to log of 17 over 2 divided by 3 log e, which this is correct, but it looks a bit different than my previous answer. My previous answer was ln of 17 over 2 divided by 3. Now, both are correct and they look different. And even to elaborate on this point a bit more, log of one thing divided by another thing, log of 17 over 2, that's the same thing as log 17 minus log 2. So you could rewrite this as log 17 minus log 2 over 3 log e. And all of these answers are correct, though they look quite different, which, as a very practical application for your homeworks, if you solve a problem in a slightly different way than the book or another person, your answers may look different. They still may be the same, but they may look different. One easy way to check to see if two answers that are different are in fact the same is you can take both answers and put them into a scientific calculator and see if you get the same decimal representation. So you could, for example, put this second answer into a calculator and this first, and if you get the same decimal, then they are in fact the same answer. Now that I've made a couple generic points about these solutions, let's go ahead and outline the solution method. So we started with our equation, and we said that this method will work if we can turn our equation into one of the following two forms: number to a power involving x equals a number, or number to a power involving x equals number to a power involving x. Is going to be to solve the resulting equation. So I'll need another sheet of paper. Solve the resulting equation for x. And this resulting equation will always be a simpler equation than an exponential equation. Typically, it will be linear. It could be another type as well, perhaps quadratic, but it will be an equation that you already know how to solve. And that's exactly what we did at the end here. We had x times some number equals some other number, and we just divide by whatever is multiplying x.